Okay, so now we're going to learn types of reactions. The first type of reaction we learned was a combustion reaction. Remember, the main feature is going to have a hydrocarbon combines with oxygen. Main clues, we're only given one reactant, which is our hydrocarbon. We must remember to add the oxygen gas. There's two types of combustion reactions. We have complete combustion and incomplete. So let's look at complete combustion. Complete combustion basic equation is the hydrocarbon plus oxygen produces carbon dioxide and water. Carbon dioxide, so 2. So here's our basic formula, and n being any integer. You will have to predict the equation. You will only be given the hydrocarbon and told how it reacts. So let's look at the combustion of methane. We have methane, we have to add oxygen, and it produces carbon dioxide and water. Remember, the way we balance this is we're going to balance our carbons first, one carbon, balance hydrogen second. We have 4 hydrogens, so we need 4 hydrogens, and then oxygens last. 2 plus 2 times 1 is 2 is 4, so 4 oxygens. Here we have complete combustion. Again, remember, carbons, hydrogens, and oxygens. We have 3 carbons here, so I need a 3 here. This gives me 6 hydrogens here, so 3 times 2 is 6 hydrogens here. Then we add up our oxygens. 3 times 2 is 6, 3 times 1 is 3, is 9. So remember, we're going to ask ourselves, is this an odd or even number? If it's an odd number, we put the odd number here and then double the coefficients. Uh-oh, why did I put a 7? Oh, because I have to subtract those 2, sorry. So we have 9 here minus these 2, which gives me 7. So then I'm going to double all the coefficients. Why do we do that? Because 7 divided by 2 is 3.5. I can't have a 0.5, so I'd have to multiply it times 2, which would give me 7. Well, what I do to one, I have to do to the other. So it's just easier to say if it's an odd number, put it here and double the coefficients. To balance a combustion reaction without oxygen in the hydrocarbon, we're going to balance the carbon and then the hydrogen. We're going to add all the oxygen on the product side together to determine the coefficient for oxygen on the reactant side. If it won't balance, put the number from B and double all the coefficients. Okay, so that's what we did. And then to balance combustion reactions with oxygen in the hydrocarbon, we're going to subtract the oxygen from the hydrocarbon. This will tell you how many more oxygen are needed. If it won't balance, put the number from B and double all the coefficients. Then we have incomplete combustion. Same exact principle, except we have carbon monoxide instead of carbon dioxide. Okay, so we're back. Now we're at double replacement reactions. AB plus CD. The cation switch places, and you have AD plus CB. The main feature, I got these backwards when writing these notes, the metals switch places to form a precipitant if the reaction takes place. The main clue is you're going to have 2 ionic compounds on both sides of the formula. Remember, we're going to always write the words first for products, because of course I gave you the others, then balance after writing the equation. To predict products for double replacement reaction, we're going to write the names of the products first. Then we're going to draw a full circle. Outside names pair together, inside names pair together to create products. Remember, each compound must have a metal and a non-metal or a polyatomic ion. We'll then write the formulas, then balance the equations. Again, going back to balancing, underline your polyatomics on both sides and balance those first. Carbons, hydrogens, and oxygens last. Alright, lead 2 nitrate plus potassium iodide. We draw our circle. Lead bonds with iodine, potassium comes back to bond with nitrate. So we write our products, lead 2 iodide plus potassium nitrate. We write our formulas. If you need to, write the oxidation numbers or the charges above and swap and drop. Ammonium dichromate plus sodium acetate. Ammonium bonds with acetate. Sodium comes back and bonds with dichromate. So we have ammonium acetate plus sodium dichromate. Now, note when you have the word acid on the reactant side, first write the formulas, not the words, for the reactants and do the full circle with the formulas to get the appropriate names. Yes, you have to go back and write the names. If you do not do this, you're likely to write sulfuric hydroxide and ammonium acid, which doesn't even sound right and most definitely is incorrect. These are called neutralization reactions, which will produce a salt in a water. So we have sulfuric acid plus ammonium hydroxide. Okay, so hydrogen bonds with water, ammonium comes back and bonds with sulfate. Remember to write an, why you didn't tell me? When you write an acid, ic becomes 8, so sulfate, and we rewrite water as HOH to balance. So that's double replacement. Hey, yeah, y'all can tell me, hey, I'm screwing up. Oh, Ethan, this look like?
I have to go to a cardiothoracic surgeon.
A cardiothoracic surgeon. What is wrong with your cardiothoracic region?
I have appendicitis.
You have an appendicitis.